Okay, so let's warm up by show of hands. So how many of you do you use Kubernetes? Nice, very nice. Okay. How many of you think that sometimes Kubernetes is not a great solution and may be overcomplicating things? Okay. How many of you want to tell your architect or management but are afraid to? None. Very nice. And how many of you are the management who thinks that? None. Not so nice. Okay. Okay, so first of all, you shouldn't use Kubernetes was obviously a clickbait, and I'm not here to tell you about Kubernetes because I have no knowledge of Kubernetes, but I will tell you about how I come to know serverless and how I use serverless on a daily basis, and how we as a company which I formerly worked with come to realize that we want to use serverless. Okay, so first of all, we've been doing some PHP web development with Docker around 2014. Symfony PHP framework, if you know it, it's a great framework for everything. We used EC2 servers, EC2 instances behind classic load balancer. We also have set up auto-scaling group, etc. We used EFS for sharing the data between these instances. We used RDS, MySQL, VPC, NAT gateway. Pretty usual. That one instance there, yes, it is for cron jobs because we then didn't know about SQS or anything like that. So we still used cron jobs, which should be connected to RDS as well. So what was the problem there? It was a pretty great setup for that time because we basically were doing a project for UK and as I know in 2014 I know no one in Slovakia who uses AWS or even auto-scaling group or whatever. So this was pretty advanced for me at that time because it used multiple servers and etc. etc. We used to patch Amazon Linux manually. We used SSH and Git deployments, and the scaling of one instance was around 10 to 20 minutes, which was not really great. That's why we switched to Docker. So first of all, I wanted to say containerization, but no, I'm not going to do that. I'm just using Dockerization. So it was still PHP. Some small infrastructure changes, as you can see. We found out that EFS wasn't really the ideal solution because it was too slow. And previously, we've been serving the files, the data to the end users through EC2 instances through Apache, and that was the really problem because we hit some limits of 255 connections per server, etc., etc. So we use the smart thing. We put the data, the assets, the CSS, and everything to S3 bucket and files, of course, upload and everything, and we served it through CloudFront, which was really great because the load from our auto-scaling group just slashed in half over the night because since we introduced this. Again, still no SQS here, only EC2, PHP, crons, etc., etc. What was the great about Docker was that you cannot tell anymore it works on my machine because it worked everywhere, every developer and every stage, either staging or production or UAT or whatever, had the same code, same dependencies, and same everything. So it was really, really nice. Around the time, around 2016, we started to introduce in some developer experience, so DX. So we started using Docker Compose, which is abstraction over Docker itself. And again, since no one in the company wanted to get around with new technology or get their hands on Docker or Docker Compose, we have built also Bash wrapper, which did basically just run the Docker Compose commands for you. That was kind of okay for the developers, but the whole company culture was really in the pain because no one knows nothing about Docker, no one knows nothing about how this scales on EC2 instance or whatever. So that was it. The problem, we're still managing servers, right? And we still scaling 10 to 20 minutes, so still not great. What's next? So this is just an intermezzo. So what was our stand there was that we hated JavaScript and we loved PHP. We hated JavaScript to extent that we didn't want to use it on front end. That was a time where Ajax calls were really popular. I think that it was around time where Backbone was introduced and stuff like that. So we've created Ajax.com, which was PHP library, which we have pushed the data. Basically, we had a small client on front end written in JavaScript, and from back end, we just pushed the HTML snippets, and the small JavaScript library was replacing them on the fly. So basically, we did Ajax calls without even touching JavaScript, only from PHP, which was great, and we loved PHP. Yes, we overcomplicated things with OOP, hexagonal architectures, clean code, PASR, and everything. So somewhere around 2018, I believe, there was a pressure from one of our clients that they had a React library of UI components, and they wanted us to use it. So since we hated JavaScript, the only obvious thing was to use JavaScript, right? So now we have on Fork on the Road on 2018, and there were multiple things which we wanted to try or use. There was a discussion about using containers. There was a discussion about using Kubernetes even. But then we kind of liked the model of AWS Lambda and the whole serverless mindset and serverless idea. And of course, since we hated JavaScript, we started using JavaScript or maybe TypeScript on front end and back end. So we threw the whole entire stack we had, and we started to build in the application for that particular client in TypeScript, backend and frontend, so it was React. There was no framework on backend. We used AWS infrastructure basically as a framework of services, which replaced all the things we've been used to use in Symfony framework. So all the authentication, all the routing, et cetera, everything has been replaced by AWS infrastructure. And from start, we used serverless framework because the AWS CDK or Cloud Development Kit was generally available only at around 2019. So yeah, so this is our first take on serverless architecture. So it was really simple application. It was English forward auction system. And we used React on S3 bucket behind CloudFront, as you can see. And then we used AppSync. AppSync, do you know, anyone know AppSync service? No, okay, so it's a managed GraphQL server service from AWS. We also use Cognito, which is basically authorization service from AWS. And behind AppSync, we used API handler in Lambda, and we put everything to the DynamoDB. And from DynamoDB through DynamoDB streams, you can basically watch all the changes within the DynamoDB. So anytime someone puts some record to or item to the DynamoDB or updates it or deletes it, you are notified through DynamoDB stream, and you can invoke Lambda function or SQSQ or whatever other services are supported at the moment. So this was pretty simple and straightforward. For us, it was really nice because Lambda meant that we just need 100 lines of code or even less, and we can, through AWS SDK, we can call all these different services. We just put some JSON data to the DynamoDB, and we don't care. But it was also not that easy because first thing we found out was that AppSync subscriptions, because it was a auction, so we wanted to tell everyone anytime someone bid on some item, we want everyone else to see the bid in the real time. So we use GraphQL subscriptions, which were real time. The only problem with AppSync at that time, I'm not sure if they fixed it or if they introduced something else, was that the subscription only were broadcasted. So you didn't have multicast or unicast, which is not that great, because when I bid something, the other party knows what I bid, which is not ideal. So that's why it says first take, because second take of the architecture looked like this. So we swapped AppSync with API Gateway, which at that time, again, did subscription model, but we only used it for queries and mutations. And then we had IoT Core MQTT Broker, which we used for subscriptions. We also got rid of Cognito because for our use cases, it was like a really nice choice for the beginning because it was out of box. It did all of the JWT and everything like that, and it had endpoints for sending SMS and emails, etc. But it was for our use case too managed, so we come up with our own JWT authorization system, which was handled by Lambda Authorizer. The same authorizer was reused in the IoT Core MQTT broker. Sorry. And that was it. Still DynamoDB, still streams, and still no SQS, as you can see. Nevertheless, that was for 2018, for the first basically application we've built, it was really exciting. Cool. That's basically the thing that we did, and from there it is almost 7 years or even more than 7 years, and we come across with other serverless services, and we use Lambda, Fargate, S3, SQS, and all of this. So that was really nice. For our use case, it was quite nice fit, but it is not like that for every use case. For instance, DynamoDB is great database if you know how you are going to access the data. The first thing you do with DynamoDB is that you define your access patterns, and then you model the data according to it. But if someone in the middle of project comes in and tells you that, okay, now we need some other access and some other patterns, that's a pretty big deal. So it's not ideal for everyone. There are ways which you can come around with it, but this talk is not about it. Sorry. So some key takeaways. Basically, every tool has its purpose. Obviously, don't forget that you are shipping the code, the service to your customers, not the infrastructure, not the tools, not the EX. For us, it was don't fight the inevitable, so don't fight that that you will become JavaScript or TypeScript developer. Simple things are hard, and that's true always. Also, Kubernetes is not always the answer. Serverless is neither, and you should always learn about your options. So basically, just go there and learn. And for us, the serverless mindset shift was about letting someone else managing our infrastructure, our cluster. So we didn't need any DevOps person. We didn't need anyone who would go there and manage clusters like Kubernetes or something like that, because that's something which we already pay for to AWS. And I think that's all from me. So thank you very much. It was quicker than I thought.
Thank you very much. So do we have any questions?
What do you hate the most about JavaScript?
Hate?
Yeah.
So many things. I don't know. I think the floating point.
PHP has it differently?
I don't remember. I think yes, but I don't know. The floating point is really a pain in the ass. So what I used to do is, or what I'm usually doing is to convert everything to cents, and then whenever I need, just to divide it by 100. And now with the big int, it's really easy because you can do all the big computations.
Okay, so just personal hate, right?
Well, at that time, it was really the things like. At that time, the JavaScript was about front end, right? So the front end things like that time the most JavaScript framework thing or library was jQuery, and I think that that explains a lot. So jQuery was introduced because the native APIs were really cumbersome. There wasn't any fetch, there weren't any document query selector or anything like that, right? So everything you needed to do by get element by tag or get element by ID, get element by whatever. So that was kind of the hate. But now, nowadays, I think that it evolved really. And since I'm working with it, I might just learn it and understand it more. So there is no more hate. Anyone else? Yep.
One question. What's your opinion or your feeling about ECS as an alternative?
ECS as an alternative. Well, to be honest, I always, my first choice is always the native way, right? Because ECS does most of the things that Kubernetes does. I have experience with ECS. I don't have experience with. I had one experience with Kubernetes, which I basically the experience was that I just deleted it and used lambdas, but that's not the good experience. But ECS is great because it's fully integrated with AWS, right? And if you are not thinking about multi-cloud strategy or on-prem versus or hybrid architectures, then I would probably go with ECS. And the control plane is included in not like EKS, which you pay for control plane extra. And I think that the integration of native AWS services for the EKS or Kubernetes is afterthought, right? The ECS it's been built to communicate with all the AWS native things from start. So it's really nice. The only problem is that ECS you are not able to run on your local environment, which Kubernetes you can. But that, for me, for instance, I use really a lot of native AWS services which are only deployed to the cloud. And there are some alternatives for local development, like even DynamoDB or S3 or whatever, but I never use those because it just doesn't make sense. There are some limitations, there are some trade-offs, but I wouldn't be scared about those, so yeah. Yeah, come on.
So how do you do the local development then, when you said that you're not using any like local abstractions?
Yeah, it's, well, depends on service, right? S3 you can access from the difference, the big difference is, do you want to develop locally offline or online, right? So DynamoDB, which I use, or S3, those are publicly accessible from the internet. So I just go through straight there. But for instance, there is SQS, which runs code in the infrastructure. So there are two options. The first option is to have a small if condition where you call the handler synchronously when you are on your local machine, or you need to deploy the changes before you run it from local and you hit the SQS. You had another question, or?
Yeah. So when you have a team like 30 developers or
Mm-hmm.
so, does every developer has an own AWS account? Or?
No. You can share the same. Well, the most problematic is database. But it depends on which database you run. If you run MySQL or Postgres or whatever, you can run your own database locally. For the asynchronous tasks like SQS or whatever, you can, to some extent, call them synchronously. But then again, you still need some test pipeline, some test environment where you can really test the infrastructure, right? So whenever I do some SQS, I'd rather redeploy multiple times to the AWS, to some dev environment, than faking it through whatever means, because those are different limits, the visibility windows and everything. Things like in the native AWS infrastructure just cannot be abstracted or faked on local development. So it's always trade-off, right? So.
Maybe I can help you. I have some experience in this area. So basically, you have two choices. You can either use like local stack, that I would say nobody uses that. So usually, teams want. Yeah. Okay, sure. Okay, but but what I see most frequently is that there's like one environment per developer, and it works very well if you have like dynamic database, which is serverless, fully serverless. But if you have, for example, something like RDS and you need to connect to that, then also people usually spin up new RDS databases. They basically like the smallest instance there is, and so it doesn't cost that much. And developer time is more expensive. And in terms of like the redeployment, so if you were to do the whole deployment like CloudFormation deployment, so it could take some time. So different cloud frameworks, such as Serverless framework or CDK or Serverless stack, they have like a development mode, which basically takes or rebuilds your code very quickly, and then just pushes it just avoid the CloudFormation. It just swaps the code, and so you have like a live version deployed in your cloud, and you can see like if you and then the framework connects to the CloudWatch logs, so you can see the logs locally. So if you, for example, have one function connected to SQS queue, and you publish something to the SQS queue, you have the feedback loop. So I believe like nowadays
there are options, yeah. There are options.
This is serverless framework.
Oh yes.
SST, what you mentioned.
They have like SST,
yes.
Even more complex and even faster feedback loop. But I would say that, and also I'm a creator of one of such frameworks, and so we also support it, and I can talk about it. But I believe Serverless framework has it, but the best options would be probably the SST or Serverless stack.
Cool. And also, you don't need actually to have multiple instances per users, but you can have one larger instance with separate databases, for instance, right? If you want to get a cheaper infrastructure. Or what we used to do was to run database locally and run the rest of the infrastructure remotely. And for instance, you don't, for development, you don't really need to deal with VPCs or anything like that. So it's really kind of nice.
But I would say the problem is that it needs to be so simple that developers can understand it. Because if you're developing in serverless, then every developer is also sort of like up to a point is also like a DevOps person. So he needs to be able to deploy their stacks and configure it. So the simpler the setup, the better, I would say. So I would do something like shared resources, because then it takes away the freedom for each developer to manage their own environment. So yeah.
It really depends on the use case, yes. I would say. Great. Perfect. Thank you.
I have a question.
Go on.
Thank you. Good presentation. Why did you highlight care about the demo? Did you mean?
Excuse me?
Why did you say us to care about good? I didn't catch it. Was good provisioning parameters or good like
So what I liked about DynamoDB? Is the question? No, sorry.
What was the problems with DynamoDB?
Oh, the problems with DynamoDB.
Yes.
Okay, so the most problematic about DynamoDB is that there are a lot of great things about it, but the one most problematic thing is that it's not relational database, and there is really, you need to have different mindset about the database itself, right? Because you, as a software engineer, as a software architect or whatever, you decide that you are going to use DynamoDB, and then comes someone from project management or whatever, and they tell you, all right, now I want to list everything here within the table with 20 columns, and all of these needs to be sortable. And there needs to be pagination because we will have hundreds of thousands of columns, et cetera, et cetera. In DynamoDB, you don't have that option because, again, there are some trade-offs. You can sort on one column per index. You can have five global table indices and I don't know how many local table indices, but it is not, the database is not built for that use case. So if you want, for instance, if you want to search something, you should use either, you can use multi-purpose database like Postgres or MySQL or MariaDB or whatever, or you can use DynamoDB and index some data which you want to search upon to the Elasticsearch service, for instance, or OpenSearch service, which is, I believe, also serverless now, but I don't know how that works now. But yeah, so the problem is that DynamoDB is great for microservices when you know how the data will be stored and it doesn't change much, right? And so yeah.
The problem is that it's called DynamoDB when it's Dynamo Data Store or Dynamo Key Value Store.
No SQL store, yeah. Yeah. But yes. But of course, it is technically a database, but of course, you need to study before you use something, so yeah.
So in summary, don't choose wrong technologies, right?
Exactly. Every use case, every technology is good for its use case, right? It's, I don't know, it's same like you wouldn't use JavaScript or PHP for something which you need to be quick, right? Because you would use Go or Rust or Zig or whatever other language. So it's the same with infrastructure. It's the same with tools, with services, with everything. Is that all? Okay, thank you very much for having me.